Hello everyone, welcome to Chip Talks with Madan. Today in this video we will see about full adder. Previous video we had seen half adder and its truth table, logic diagram and some of the limits, what is the limitations and what is the output and inputs of the half adder. So in half adder we had some limitations like this. The previous input should not be carry. Okay, to avoid this we will going to study about full adder. In this we had no limitations. The previous value we had carry, so we can using full adder we can add multiple bits. Okay, let's start the video. In this video we will see about what is full adder. So, same, it is a combination circuit. It will add three binary digits, three binary bit, like first point. It will add three binary bit inputs, binary bit inputs. That is, we can tell A, B, and previous input. Previous value means carry in. C, we can mention C in. So there are three inputs in full adder: A, B, and C in. C in refers to previous bit value, previous carry value. And in this, we will have output same as half adder. Outputs same as uh, half adder. That is, we can tell sum and carry. There is no limitation in full adder. Why we choose full adder compared to half adder means in half adder we had only sum and carry. There are only two inputs, two binary inputs we can add. But in a full adder we can add three inputs. Okay, so there is no limitation in full adder compared to half adder. So we preferred full adder rather than using half adder. And we can also define full adder using two half adder. In this video only we will focus on full adder, only three inputs. Next video we will see about how the full adder is built using two half adder. Next, let's see about the truth table of full adder. I will open one note. I think, okay. This is the full adder diagram, block diagram. See, A, B, and C in. C in refers to previous state input. This full adder and two outputs, sum and carry out. This is full adder block diagram. Wait, I will make, okay, A and B and C, two outputs. Next, Next, I have previously told A, B, C in. A refers to one input, B refers to one input, C refers to previous output. In this, there are A0, B0, and C in. C in refers to previous values. No, they had nothing carry. So we mentioned 0. So the output sum and carry is 0. Next, 0, 0, and previous value it had 1. So it make us 1. Sum 1, carry 0. Same as next 001, 00012, 3, 4, 5, 6, 7, up to 7. If you see means these are the values. Next, using this sum carry, we will make a K map. Like I will draw a simple 0, 1, 2, 3, 4, 5, 6, 7. Sorry, 0, 1, 2, 3, 4, 5, 6, 7. Next, here A, here B is B, C, N. Okay, where the values are one, we should make one like one here one like that. I'm making example. So in this value, we should make K map. You already, I think, in digital K map is very important. So using K map we can define that sum and carry 1 1. So using this, we had a some value. See sum and carry. Okay, sum is XOR gate and carry is OR gate. See here, A, B and C in. Both are A XOR B is the input of here and C is the input. Both are inputs of that sum. Will make us B XOR C with the sum. Next, from this we will make out C output. So C C in is the input and A XOR B is the input of that OR gate, sorry, AND gate. Is the same. A and B is the input of AND gate. From this, they are making input of OR gate. They are making C out. This is the uh, logic diagram of sum and carry. See here. Wait, I will show that. I'll show that half adder. See here. Sorry, so this is full adder. I think full adder. In this, we had see here. I told previously A XOR B, A XOR B, A XOR B, B XOR C. This is the sum. Okay. And C out. See A, B, A and B plus C in uh, and A XOR B. And this both are combined using OR gate. This house the this house the full adder works. So we can recall that topic. Full adder has three inputs. One is A, B, and carry in previous state inputs. It has same as the output of sum and carry. There is no limitation like half adder. We can build using full adder using three inputs, or we can build using full adder using we can build full adder using two half adder. In this video, we had seen full adder using three inputs, that is A, B, C in, and we had seen the truth table. See 0 0. Like whenever the carry comes, we should mention that carry is 1. Whenever sum comes 1, we mention sum 1 and carry is 0. Next, this is the logic diagram we had seen, and block diagram of this is the block diagram. A, B, C in and full adder sum and carry out. So in this video we had seen full adder and its layer no and its how it's formed and its truth table and its logic diagram and its block diagram. If you have any doubt, ask in the comment section. And soon we will see that examples of K map. That's so you will understand that how the K map works. So if you understand that K map means, it will easy to make that logic equation easily. So we will make it in the next video. Okay, bye from Madan. Thank you for watching. See you in the next video. Bye.